In this lesson, we're going to talk about how you graph points onto the coordinate plane, and we're going to talk about some of the special shapes that show up a lot in our algebra class, and what happens when we move these special shapes around the coordinate plane. We call these transformations. So to start off with, we need to remember that an ordered pair is some x and some y value together, so something like x comma y. And these two values make an equation true. You can also call these solution points. So, to review graphing, we're just going to start by filling out a chart, getting some y values over here on the side, and graphing them. So remember, your x values over here are your independent values. We plug those into the equation. We simplify and get y out. So 3 times -2 minus 1, 3 times -1 minus 1, 3 times 0 minus 1, 3 times 1 minus 1, 3 times 2 minus 1. We simplify these. Okay. And then this is your y-axis, this is your x-axis. We'll go ahead and plot our points. Five, 6, 7. Okay. And when we connect all of these points, we get a line. Okay. Now, giving 2 more ordered pairs, which would make this equation here true, lots of ways we could do this. We could just add more points to our chart, like 3 and 4, in which case we would get 8 and 11. Or you could look at the points on your line. You could follow your line and say, oh look, there's a point up here. And this point is at 3, 6, 7, 8. So point 3, 8. Or you could look at this point right here in the middle. This one right here is at 1.5, 4. So 1.5, 4. Or we could look down here and go at -1/2, I'm at -3. -0.5, -3. There's infinitely many points that are on this line. And this is true for any equation. Anytime there's an equation with 2 variables, so an x and a y, there are an infinite number of solution points that will make it true. So, not just those 5, but every single piece on this line is a dot that would work. Alright, we're going to look at some different shapes, practicing the same skill. Here's this shape, it's x squared minus 5. So plug in our values. Now, be careful for this one. Make sure you're squaring the x term. You're squaring the entire thing. So you need to say, I'm squaring -2 minus 5. Some people go ahead and they just put, oh, I'm going to have -2 squared minus 5. That's wrong. You need your parentheses whenever you've got this little squared thing in there. So -2 squared is 4. 4 minus 5 is -1. Finish up your chart. And when we get our y values and we plot these, and I know I am doing these quickly, you can pause it if you need to. But this shape, this is what we call a parabola. We're going to study these in Chapter 5 later in our year. Okay, what you need to know is that there are many shapes that we talk about. And when we talk about shapes, we call them parent equations. Many. Here's just a couple. One of them is the absolute value, and it's this V shape that heads off like this. One of them is a square root. That starts at the origin and it rises gently to the right and keeps going. One of them is the one you just saw. It's an x squared shape, and this is the parabola shape. Now, the one we just saw on the other page was a parabola that was moved down here. That's called a transformation. Anytime you apply a change to a parent function, again, you can do this symbolically, like y equals x squared minus 5. That's a change algebraically. Graphically, it would be like, oh, I'm not going to start here. It's going to start all the way down here. Any changes like that are called transformations. Okay? So we're going to explore how the different types of transformations, and there's several different types. We're going to see 4 different types of transformations, how changes in the algebra will affect the graph. And in order to see these changes, we're going to focus on just one special shape. So we're going to focus in on this absolute value shape that you see right here, which is that V shape. So first, here's the parent function. There's no changes. Let's plug in our values. And remember, when you have an absolute value of a number, it takes whatever that number is and turns it into a positive. So negative 2 becomes positive 2, negative 1 becomes positive 1, 0 stays 0, 1 stays 1, and 2 stays 2. So when we graph these, and we connect the dots. That's our high V, or the absolute value shape. Okay, and now what happens when we add a change, when we add a transformation? This little guy in here, he's a transformation. He's something different that we didn't see before. So we're going to plug in the same x values again, see how it changes the numbers, and then look and see how it changes the graph. So absolute value of 2 plus 3. So this becomes positive 2. Positive 2 plus 3 becomes 5. Positive 1 plus 3 is 4. 0, 3, 1 plus 3, 4, 2 plus 3, 5. Notice that it's the, whoops, that was bad. Let's do that. Notice that it's the same shape that you see as before. It's still that V shape. It's not a parabola. It's not a curve. But the V absolute value shape. But notice how it's different. Before, we saw it here at the origin. Now you're seeing it shifted up. And specifically, it's shifted up 1, 2, 3 units. We also had this 3 at the end here, so pay attention to that. That's going to be part of our pattern. The graph moved up when we added 3 to the outside. Let's look at another example. So go to page 20. This time, we're still going to add 3, but we're going to add 3 to the inside of the equation. See how that changes it. Okay, so 2 plus 3, we get 5, 1 plus 3, 4, 0, 3, 3. Negative 1 plus 3 becomes positive 2. Negative 2 plus 3 becomes positive 1. So when we plot these points, we start to see this. And first of all, we should stop and ask ourselves, wait a second, this is an absolute value. Why don't we see that high V shape that we're used to seeing? My hint to you is that right now, you're only looking at this much of the graph. That's the only portion that you see. We need to see more points to either side to really get a better picture. So let's add some points on this left-hand side. Let's throw in a negative 3 and a negative 4. So negative 3 plus 3, negative 4 plus 3, This becomes 0. So that's this one. Negative 4 plus 3 is negative 1, but absolute value of negative 1 is positive 1. Oh, look, it looks like it's starting to turn. Let's do another one. Let's throw in another point. Let's throw in negative 5. So this becomes negative 5 plus 3. That's negative 2. The absolute value of negative 2 is 2. Negative 5 comma 2. There we go. Now we see this high V shape. And again, it's the same picture as what you saw before that started here at the center. But now it has been moved over to the left, and it's moved over 1, 2, 3 units. So shifted left 3 units. So when it was on the inside, it moved left 3 units. Let's try the 3 in another position. We've seen it on the outside, we've seen it on the inside. Now let's see what happens when we put it in the very, very front. So for this one, 3 times the absolute value of negative 2. Absolute value of negative 2 becomes positive 2. 3 times positive 2 becomes 6. 3 times positive 1, because that's the absolute value. 3 times positive 1 becomes 3. 3 times 0 is still 0. 3 and 6. So let's graph our points. All right, let me move it up. All right, there we go. So here it is. Okay. Again, it's a high V shape, but before that high V shape looked more like this, right? This one is really narrow. It's really steep. In fact, if you look at it, it's stretched. Like here, the point was here. Now it's moved up to here. The point was here, and it's all the way up there. So it's stretched. We're going to say tall and narrow. That's what the 3 in front did. It still started in the same point. That didn't change, but it made it skinnier. So, lots of different things that happen with 3s. Let's try something that doesn't have a 3, but it's an important change. This change has a negative on the outside of the absolute value. So let's be really careful with this one. Here's that negative. Then there's absolute value of negative 2. So this becomes a positive 2 here, but that negative is still sitting out from here. So that's the negative, and then the positive 2 from the absolute value. Same thing. This negative becomes a positive, so it's positive 1, but there's the negative, so negative 1. Negative, absolute value of 0, and again, 0 is not positive or negative, so it stays 0. Negative, so this one becomes negative 1, and 2, so negative 2. So this shape, same shape, right? Except it has been flipped, or the math term we're going to use is reflected. It has been reflected over the x-axis. It's like the x-axis was a mirror, and it's flipped across it. So if this is the mirror here, it's a mirror image across that line. That's what the reflection means. That's because of this negative right here. So let's talk about some of the patterns that we just saw.